So in this video today, we'll solve some exercises from the final exam of last year, 2019. This questions covers trigonometry, and question 3 of this exam. So we are asked to find the real number x such that these two angles are supplementary. So what's the definition of supplementary angles? So two angles are supplementary if their sum is 180 degrees. So this means that this is the angle 1, this is the angle 2. Angle 1, 3x minus 3, plus the angle 2, x plus 7. The sum must equal 180 degrees. So this gives us a linear equation to solve to find x. So we remove parentheses. So we have plus multiplication. We collect x's, 3x plus x, 4x. 7 minus 3 plus 480. So 4x equal 176. So x is 176 over 4, which gives 40. So this is the value of x. So here the correct answer is it's not 44. Why? Because the angles are not x. We are not requested to find x here, but to find these two angles. So the angle 1 is 3x minus 3. So since x is 44, so it's 3 times 44 minus 3, and this gives 120. The second angle, x plus 7, is 44 plus 7. This gives an angle of measure 51 degrees. So the question here is not to find 3x, to give the value of 3x minus 3 and x plus 7. Not only x, but we have to find x first. The second example, here we have a right triangle. So this is a right angle. We are given the hypotenuse, which is the side opposite to the right angle, and we are given an angle 23 degrees. And the question is to find the length of this side. So here, how to find the length given an angle, and with respect to the angle 23 degrees, A is the opposite side to this angle. So we have a triangle in which we are given an angle 23 degrees. We are looking for the opposite side, and we are given the hypotenuse. So which trigonometric function use opposite side and hypotenuse? Here it is sine. So sine of theta, we also all know that it's opposite over hypotenuse. So here, if we take theta equal 23 degrees, we'll get opposite side is A and hypotenuse is 15. So A equals, so we multiply by 15 here to remove the denominator. So A equals 15 sine 23 degrees, which is 5.86 up to 2 decimal places. Question 7, dealing about odd and even functions. So here we are given 4 different functions, f, g, k, and h, and we want which of the function is an odd function. What's the meaning of odd function? Function is odd if f of minus x equals minus f of x. So here this minus is outside. This is the definition of an odd function. So here the correct answer is the first choice. Why? So first step, we write f and we replace the variable by parentheses. What shall we put in this parentheses? We put minus x instead of x. Okay? And then we try to simplify. So we have parentheses, but we have nothing in front, so we can remove them. Cosine. And what about cosine minus x? We know that cosine is an even function. What does it mean, an even function? This means that cosine of minus x equals cosine of x. So here we remove the minus, cosine. And we have to compare this function to f of x. But this part is exactly f of x. So it's minus f of x. So we see that the minus here is outside. So this function is okay. There is another way to say it. So we know that cosine and sec are even. We know that sine, tan, cotan, cosec are odd. We know that polynomials, monomials with odd power are odd. So x, x cubed, x7, all these are odd. Polynomial or monomial with even power are even. So x squared, x4, x6, constant, so 5, minus 3. So all these are even functions. So here, in this example, x is odd because it's monomial with odd power. Cosine x is, cosine is even. So here we have a product, odd times even, and this gives odd. Okay? In this example, sine is odd. Sine is but sine square is the product of sine times. So odd times odd gives, odd times odd gives even. So sine square is even, and the constant minus 1 is also here. This is a constant. And sine square is even. So we have even minus even. If we add or subtract even function, we get. Here, sine is odd. Cosine is even. Odd plus even gives nothing. Neither odd nor even. Here, x squared plus 1 is an even function. Because x squared is even and constants are even. Cosine is even function. So even over even gives. So if you multiply even function or you multiply odd function, you get even. So even times even gives you even. Odd times odd gives you even also. Odd times even. Odd plus odd is odd. Plus or minus, of course. Even plus or minus even gives you even. So these are the different cases. Now, how to find graphically the trigonometric functions. So there are several ways to find the graph associated to this function. The first is that it's a sine function. So sine function must pass through the origin. So all these are sine functions. All the graphs passes through the origin, 0, 0. Here we start, the coefficient is negative. So since the coefficient is negative, the sine passes through the origin and then must decrease because this is a negative. A is negative. So it must decrease and then increase. So this cannot be the right answer. Must decrease first after the origin. Because here we have a negative number. But the most effective way to find the graph here is to find the period of the function. But the period P. So here f is of the form a sine bx. So the period is 2 pi over b. What's the value of b in this example? In this example, we have sine x over 4, which can be written as sine 1 over 4 times x. And this is b. This is b. So here b is 1 over 4. So division is a multiplication. So we multiply by the reciprocal, and so the period is 8 pi here. So how to find the period graphically? To find the period graphically, 3 ways. Remember, it's the distance between two maxima. This is the period. Or the distance between two minima. This is the period. or the distance between one, this is also the period. So when the function make complete. So here in this example, the period starts from this point minus 4 pi until this point 4 pi. So the period, the difference 4 pi minus 4 pi, so it is 8 pi. So this is the correct answer. Here the period is 0, 1, 2, 2 pi. So here the period is 2 pi only. Okay? Here, in this example, the period, I can compute here, 0, 1, 4 pi. So here 4 pi minus 0, so it's 4 pi only. So no, this is not correct. So the correct answer is the domain of inverse trigonometric function, arcsine. What is the domain of arcsine? Arcsine is defined when the arguments here 2x minus 1 is between minus 1 and, so this is an inequality, linear inequality. We have to solve it, so we add 1 to all sides, and then we divide by 2. So since it's positive number, so we keep the same direction, and we get 0, 1, this is the total. Addition and subtraction identity. Identity for the cosine of the sum and cosine of the difference. What is cosine x plus y? Cosine x plus y, the formula says it's cosine x cosine y minus sine x sine. What about cosine x minus y? Same thing, cosine x cosine y plus sine x sine y. So here, cosine, this is switch it. Now we want the difference between these two quantities. We have to be careful when we, so the better thing to avoid mistakes is to use parentheses. So this is the first quantity, minus, we open the parentheses and we write the second quantity, cosine x cosine y plus sine x sine y. To avoid mistakes, use parentheses, especially when we have subtraction. So just remove parentheses and it will be easy. Sine x sine y minus cosine x cosine y minus sine x sine y, and we simplify. So cosine x cosine y minus cosine x cosine y. Here and here minus the same quantity, it gives minus 2 sine x sine y, the correct. What's a unit vector. So this is a vector. We want to find x such that it's a unit vector. By definition, is a unit vector. Vector is unit when its magnitude equals 1. What's the magnitude of a vector? It's the square root of the first component plus the square of the second. It's square x square plus 1 over. But we said that it's a unit vector. So its magnitude is 1. So we get an equation to solve in x, which is square root x squared plus 1 over 4 equals. So first step to remove the square root, we take the square over both sides. X squared plus 1 over 4 equals 1. So x squared is 1 minus 1 over 4. 1 over 4 is 3 over 4. So x is plus or minus square root 3 over 4. Plus or minus square root of 3 over